allocation of frames. How does the operating system allocate the fixed amount of free memory among the various processes? First section, minimum number of frames. The strategies for the allocation of frames are constrained in various ways. The operating system must allocate at least a minimum number of pages to each user process. One reason for allocating at least a minimum number of frames involves performance. Obviously, as the number of frames allocated to each process decreases, the page fault rate increases, slowing process execution. In addition, when a page fault occurs before an executing instruction is complete, the instruction must be restarted. Consequently, we must have enough frames to hold all the different pages that any single instruction can reference. For example, consider a machine in which all memory reference instructions may reference only one memory address. In this case, we need at least one frame for the instruction and one frame for the memory reference. In addition, in one level, indirect addressing is allowed. For example, a load instruction on page 16 can refer to an address on page 0, which is an indirect reference to page 23. Then paging requires at least 3 frames per process. The minimum number of frames is defined by the computer architecture. For example, in IBM 370 embassy instruction, since the instruction is from storage location to storage location, it takes 6 bytes and can straddle 2 pages. That means the instruction itself will straddle 2 pages. The block of characters to move and the area to which is to be moved can each also straddle 2 pages. This is A, it is the source, and B, it is the destination. So we can see A may be straddled 2 pages and B may be straddled 2 pages. So this situation would require 6 frames. Of course, this example, we say it will require at least 6 pages is the worst case. Okay. Maybe A, B, and also the instruction itself are all in one page. Of course, this is the best situation. Okay, but as the operating system allocate frame to the process, it must consider the worst case. Okay, so allocation algorithm. The minimum number of frames per process is defined by the architecture, of course, the instruction side. The maximum number is defined by the amount of available physical memory. The major allocation schemes: first, fixed allocation; second, priority An alternative to recognize that various processes will need differing amounts of memory. So consider a system with a 1 kilobyte frame size. If a small student per size of 10 kilobytes and an interactive database of 127 kilobytes are the only two processes running in a system with 62 free frames, it does not make much sense to give each process 31 frames. So to solve this problem, we can use proportional allocation, in which we allocate available memory to each process according to its size. Let the size of the virtual memory for process Pi be Si, and define the altogether of the processes in the main memory, the logical pages. Okay, this one. In M is the total number of frames. So allocate for each process AI of physical frames by using this formula. This is proportional allocation. Okay. Of course, we must adjust each AI to be an integer that is greater than the minimum number of frames required by the instruction set, with a sum not exceeding M. Okay. And the second, priority allocation. Use a proportional allocation scheme where the ratio of frames depends not on the sizes of processes, but rather on the priorities, or on a combination of size and priority. Okay, section 953, global versus local allocation. Another important factor in the way frames are allocated to the various processes is page replacement. With multiple processes competing for frames, we can classify page replacement algorithm into two broad categories: global replacement and local replacement. Global replacement allows a process to select a replacement frame from the set of all frames, even if that frame is currently allocated to some other process. That is, one process can take a frame from another, while local replacement requires that each process select from only its own set of allocated frames. With a local replacement, the number of frames allocated to process does not change, while with global replacement, the number of frames allocated to the process may change. One problem with a global replacement algorithm is that a process cannot control its own page fault rate. The set of pictures in memory for process depends not only on the paging behavior of that process, but also on the paging behavior of other processes. Therefore, the same process may perform quite different because of totally external circumstances. Such is now the case with a local replacement algorithm. In the local replacement, the set of pages in memory for process is affected by the paging behavior of only that process. Local replacement might handle a process, however, by not making available to it other less used pages of memory. Thus, global replacement generally results in greater system throughput and is therefore the more commonly used method.